Hello everyone, welcome to this presentation where I'll be taking you guys through the inverse Laplace of s over s squared plus 4 altogether squared. So first, we have to review a table of Laplace transforms to determine a relationship for this expression. So as we can see, we have our Laplace table over here. And the goal in this particular problem is to express this function s over s squared plus 4 altogether squared as a derivative of some other known function. As we see, because the form looks like it's a derivative of some known function. As you can see from the Laplace table, when f of t is equal to the sine at in number 5, we have that the Laplace of ft is equal to a over s squared plus a squared. And in our other slide, we see from problem from 19 that t to the power of n times f of t corresponds to the Laplace of negative 1 to the power of n and f to the n order derivative of s. So from this, we can take ft is equal to sine at, and thus Fs is equal to a over s squared plus a squared. And we can also now apply our formula t to the power of n times ft is equal to negative 1 to the power of n times f to the n order derivative of s. Um, and the first derivative of f of s, taking f of s to be this function over here, is going to be f prime of s is equal to negative 2s times a over s squared plus a squared. And as we see in this problem over here, a is equal to 2. So we'll take a equal to 2. And plugging in our value for a, we have that f prime of s is equal to negative 2s times 2 over s squared plus 2 squared. And that is equal to negative 4s over s squared plus 4. And as we see, now we can apply this formula over here. Um, and we can say that t to the power of 1 times the Laplace of a over s squared plus a squared is equal to negative 1 to the power of 1 times the first order differential of f of s, which is equal to, as we found, negative 4s over s squared plus 4. Uh, oh wait, and sorry, I forgot to square this because this is basically applying the quotient rule for derivatives. And we have to remember to square the denominator. So after that, we can notice that the Laplace of a over s squared plus a squared is equal to sine of at. And as we said earlier, we take a equal to 2. So this means that t times sine of 2t is equal to -1 to the power of 1, which is -1, times -4s. So positive 4s over s squared plus 4, all that squared. And dividing both sides by 4, as you can see, to get rid of the 4 over here, so that we have our original form s over s squared plus 4 altogether squared on the right hand side, we will get t over 4 times sine 2t is equal to s over s squared plus 4 altogether squared. And as we see, this matches D. So D is the correct answer. Thank you for this problem, and thank you to my sister for borrowing me her pen, and see you in the next video.